Hi there, everybody. Welcome to Session 4. This is our differentiation professional development with a focus on math. And so today's topic is multiple intelligences, which I think probably everyone has had a fair amount of experience with, whether it be in an education preparation program at a university, or just kind of informally through schools, through professional development. And just as we get to know kids, right, we know that kids come with all types of intelligences, and sometimes those are in line with the way that we teach, and sometimes they may not be. So we always have to be cognizant that we tend to teach initially the way that we learn. And so whether it be Howard Gardner or anyone else, they've kind of pointed out to us that we need to think about not everybody's going to learn in the same way that we do. So multiple intelligences definitely falls into the category of ways that we can differentiate our math classroom. So we're going to look at some of those examples here today, but before we jump into that, we'll just kind of look here at our series of sessions. So this being session 4, our next 2 sessions, actually our next 3 sessions will also be online. One of those was scheduled originally to be face-to-face. But we have changed that. That happens to be the day of the Magnet School Lottery, which I need to be at. So I apologize for making more of this online. However, several of you have said that you appreciate the online format and its flexibility for your busy schedule. So we'll be moving into concrete, representational, and abstract as a way to think about differentiating for our kids as well in our next session, and then you see the rest of the topics there. These are just the same reminders we have each time. Make sure that you're scheduling time for this professional development, just like you would for any face-to-face PD. It's easy. We all get plenty busy. Sometimes it's hard with online PD to set that time aside. Do take the time to share, please. If you have resources as we go through multiple intelligences today, or any of the topics as we work through, post those to our Edmodo group. I love adding things to the sessions for upcoming groups. So please do share. That helps me make this more beneficial for teachers now, but especially for future offerings of this professional development. And we want to make sure we keep a growth mindset. We know that I know personally that many of the things that I was firmly believing in as a young teacher, I've come around on some of those things and realized maybe I didn't know as much as I thought, and some of those other things that that I believed then are still certainly true now. So we all want to keep a growth mindset and know that just like our kids, we're all learning as we go through this teaching profession. So this is one thing I thought that it was shared by one of our school counselors, and this website is one that I thought some of you might like, because as we talk about a differentiated classroom, sometimes noise becomes a factor, right? So this is called bouncyballs.org, and you can change them from balls to emojis to bubbles to whatever you want to make them. But what you'll notice is that right now my microphone is off with this tool, so you're not seeing them move at all. But when you see I turn my microphone on, then you'll see the louder I talk, or if I do something like snap, you will see them bounce. So I've seen this used in a couple of classrooms already, and it's pretty fun to see the way that kids respond to this. It's just another way to kind of monitor class volume levels. Saw one teacher put a line across her dry erase board or smart board, and so they said, the balls need to stay below this line. You can adjust the bounciness of the balls, so you're adjusting the decibel levels, right? So if you want them to really bounce around, if this is a really quiet time, then you're going to set it really high, and if kids can be louder, then you can set it really low. But generally, you're probably just going to leave it at the same level and talk about how high the balls can bounce. So I thought this was just kind of a fun addition to our tool set as teachers, and gives us another way to kind of help our kids learn to self-monitor. So that's Bouncy Balls, and if that's helpful to you, then great. Certainly is not limited to just multiple intelligences here today. So as we look at our multiple intelligences and just in general differentiation, we remember that differentiation is a mindset and not just a specific strategy. However, as teachers, we need specific strategies that reflect that mindset, of course. So today's we're going to use estimation as a strategy that is used K-12. So no matter how advanced we become in our mathematics, we're always asked to estimate, to look for reasonableness, to think about do we really know what we're asking in a question. Those kind of things can be assessed sometimes quickly through estimation. However, I also am a believer that sometimes estimating is more difficult than just doing the math. So we'll go back and forth on those a little bit, but we're going to look at 4 different lessons here. Again, each one focused on a specific grade band. So in K2, we're going to do one called Making a Good Guess, and then you can see the other 3 topics there. So let's go ahead and progress towards that. In a preparation for this session, you were asked to do a little online homework, and that was through kind of just more of a fun website, certainly not a scientifically valid or reliable resource for intelligences, but just kind of a fun way to think about who are you as a teacher or as a learner. And several of you have shared those through Edmodo, and we certainly ask you to do that as your homework assignment in preparation for today. And if you didn't do it yet, that's okay. Put the link here on the screen. Go ahead and do it and submit that with your response for the previous session. The assignment was to go to a Real Me and to look at the 16 different types that they identify in terms of just the ways that we think about things differently. So this was mine, so I think it's always good to just disclose where we each are. And so mine came out as a philosopher, right? And it said that, so you can see the description there, but to me it's more important that we look at that radar diagram on the top. It goes in line with what we believe about gifted learners, that we all have these jagged profiles, right? There's things that we're really good at. There's things that we really aren't as strong at. There's things that we prefer. There's things that we don't prefer. And there's no normal or average gifted learner. There's no normal or average person out there. We might be average in certain areas, but not in all. We might be advanced in some areas, but not all. So when I look at mine, I can see that the areas that I probably scored the most in or the highest in were kind of in the introverted category, the feelings category, kind of high in perceiving, but not very high, obviously, in extroverted if you're in that high and introverted. So you kind of take these things for what they're worth, but as a teacher, it's interesting to know our students in this way, because if we understand how their intelligences differ, I believe it helps us to connect with them on a different level. So if I understand that these kids over here, or these 5 kids, are really just highly introverted kids, they're going to interact with me differently as a teacher. I might, if I don't know that, I might think, well, they just never raise their hand. They don't ever participate, or man, why do they always come to me at the end of the lesson and ask me 7 questions when I ask them if they had any questions, or to share their questions on with me. Maybe I need to build in some strategies where my introverted kids can provide questions, maybe anonymously, or we're going to do things on sticky notes. So it can impact, of course, the way that we teach. And one of you shared with me your radar diagram, and so I asked if I could share this with the group, just so you can see some of the different categories. So this person was also rated high on the introverted scale, which, just as an aside, I think some people might be surprised how many teachers are really introverts, because we might think, well, you're going to stand in front of the class and deliver information and do those things, but that's not always true, right? And so a lot of times teachers do tend to be introverts. So take that for what it's worth, or I guess what we learn from that. But this person was very high on sensing, but very low on feeling, where I was kind of the opposite, high on feeling, but low on sensing. So maybe I have great empathy, but I'm not always good at knowing when to use it. And so, again, we don't want to read too much into these things, but this person was very high on the thinking category and not as high on the feeling. So you see how these things play off each other. Of course, these are always interesting to do more than once, to see if you kind of score the same way, if you answer the questions in similar ways. I'm not advocating that we should do this kind of thing with all of our students, but it might be interesting to kind of, or to delve into what kind of students do we have, right? I always think when we talk about, well, last year's group of students was this way, and this year's group of students is very different. I always kind of wonder if that's just that we're seeing a lot more of a certain learning style, a certain behavior style in that group, and that sometimes we don't always recognize it right up front of what's going on. So as we think about multiple intelligences, we have a short video here to share, and so I need to check and make sure that you're going to be able to hear this when I click on it. So I'm going to pause just for a moment and we'll be right back. All right, so here we go. I believe we'll see this video. It's about 4 minutes long and just gives us a chance to kind of think on this and get a similar experience. So this comes from TED Ed. If you aren't familiar with ed.ted, these are videos that are meant to be used by teachers, are also meant to be used with kids. So some of these are great for good Socratic seminars, good discussions. So let's go ahead and take a look at this.
Dr. Howard Gardner is an American psychologist and senior director at Harvard University. He has received numerous awards and is known around the world for his theory of multiple intelligences.
The idea of multiple intelligences comes out of psychology. It's a theory that was developed to document the fact that human beings have very different kinds of intellectual strengths, and that these strengths are very, very important in how kids learn, and how people represent things in their minds, and then how people use them in order to show what it is that they've understood. If we all had exactly the same kind of mind, and there was only one kind of intelligence, then we could teach everybody the same thing in the same way.
Let's take a look at the 8 unique intelligences Gardner suggests. How do you learn best? Perhaps you will identify with one or more of the following intelligences. Mozart, U2, and Michael Jackson all had an ear for music. Those adept at reading, composing, and playing music may possess musical intelligence. Meet the needs of this intelligence by incorporating song and rhythm into your classroom. Does architecture and photography interest you? Can you find your way with a map and compass? People who love pictures, puzzles, and maps are often considered to be spatially intelligent. Incorporate these elements into your classroom to meet spatial needs. Take a nature walk, watch tadpoles morph into frogs, or study the Great Barrier Reef. These are all great examples of how to meet the needs of the naturalist intelligence. Studying the natural world is how the naturalists worked. Keep a journal? Do people say you have a way with words? Those with linguistic intelligence, or word smarts, may enjoy learning new vocabulary or investigating word origins. Get moving. Do the robot, play a sport, or act out a novel. These are all ways those with bodily kinesthetic intelligence use their gifts. Considered daydreaming to some, critical thinking is the cornerstone of intrapersonal intelligence. This type of intelligence is useful in the classroom as students analyze essays and deconstruct arguments. Excellent listening skills, the disdain for injustice, and empathy are all characteristics of the interpersonally intelligent. Conversation with others keep these students engaged. And finally, once considered the main concept of intelligence, logical mathematical intelligence encompasses a love of problem solving and strength of math and logic. The advancements of science and technology will never be enough for this intelligence.
So probably more of just a review for most of us about what's involved in multiple intelligence, or what multiple intelligences, or what Gardner proposed. And so we might think about this in terms of differentiation and think, well, okay, so how does knowing that somebody is bodily kinesthetic impact my strategies for differentiation? And I think they laid out a couple of those just in general ideas in the video there, that if I'm bodily kinesthetic, I've got to think about not just, hey, we need to go up and get outside all the time, but that movement is going to be important to me, right? And to some people, it might be as simple as rocking, or it might be as simple as, you know, tapping their foot, or but for others, it may be that they express what they know through movement. And so those can certainly bleed over into some of the other intelligences. They mentioned in the musical piece of things that, you know, rhythm is really important to a lot of kids. That if they can see rhythm, and, you know, mathematics is a lot about rhythm in terms of patterning. So how do we work those things into our lessons? And we know that we're only one person as the teacher in the classroom, so we can't do everything with every lesson, but are we being responsive to, or how can we be responsive to what our kids need in terms of their different intelligences, and are we giving kids that chance to share it back with us? So at this point is usually when, if we were face to face, when somebody would say, that's great, Michael, but when they sit down, they have to take a paper pencil test, and that's not any of those intelligences. And there is definitely some painful truth in that. However, we're also talking about the learning experiences, not the summative assessment piece. So what I believe Gardner's research will tell us, and what a lot of other research tells us, is if we meet the learning needs of kids, they can show us ultimately that they know it on something as simple as a multiple choice type test. Now, if all we give them, though, is multiple choice type tests to get ready for a multiple choice test, they're not going to get there, right? You can't just practice multiple choice, because if I disengage as a learner with multiple choice, I'm disengaged with the learning process. So when I take the test at the end, that's going to show. So that's maybe one of the responses when it comes to differentiation in general, but especially as we're talking about multiple intelligences. It's okay to learn in one way and to show at the very end that I've learned it in a way that maybe isn't my greatest strength, but I'll be okay with that because I've really built up this deep knowledge that I can reflect on that multiple intelligence test, right? So you have that multiple intelligence test that if you've already done it and submitted it, that's great. If you haven't, that's fine. Just you can submit that with this session. So the multiple intelligence test, sorry, I'm confusing two things. So I'm thinking about the one that we just looked at. But so let me pull up, this is what I'm going to ask you to do for your assignment following today's session. So let me pull up the right file here. So you will see in the attachments in our Edmodo today, sorry, let me get that in the right place. This is just a variation on Gardner's multiple intelligences test. It's a variation that happens to be free, so we're going to use that with this group. So you will see the directions here on the screen. You are looking at each of these categories. It took me a second to figure out how the site had laid this out, but you're scoring it. I mostly agree with the statement. I slightly agree as a 2. I slightly agree as a 3, and I mostly agree as a 4. So for each statement, you're going to fill in the little white box on that row. So you're going to ignore all the other boxes on that row. So I like to learn more about myself. You know, for me, that's a mostly agree. Like I like to figure out, why do I do things? Why do I think this way sometimes? Why do I get upset in certain situations, but in others I'm pretty carefree? So I can play a musical instrument. Well, I'm going to say 2. I would love to be able to, but I'm not very good at that. I find it easiest to solve problems when I'm doing something physical. That's kind of an in-between one for me. This is where I wish it was a 5-point scale, because I go in the middle. But I'm going to say if I err on one side, I'm probably more towards slightly agree. So obviously I'm not going to go through each of mine, because that doesn't benefit you at all. But when you get to the end, scroll to the end, there are about 75 of those, so it's going to take a few minutes. You'll see that this will tally up for you, and it should give you an idea then, where is your strongest intelligence type? Where is your lowest, right? Again, there's no right or wrong. In the same way that when we looked at those radar diagrams a few minutes ago, there's no great benefit to being an extrovert versus an introvert. There's times that each is a great strength. There's no great advantage to being in spatial visual versus linguistic. Now, I did like in the video how they just gently brought out that in the past we viewed logical mathematical as probably the greatest of intelligences, but as we're learning moving forward, that's certainly important to be logical and mathematical, but our brightest people have not always been the logical mathematical people. A lot of times our brightest, most adept people are more creative people, and they fall in terms of intelligence types into one of these other categories. So what I'm asking you for your assignment to do for this session is to go ahead and fill all these out, and then in the assignment piece you'll respond and let me know what's your greatest strength, what's your greatest intelligence type, and then how does that impact, how does knowing that about yourself help you help your students, or what does that help you become aware of for you? And again, I totally understand that most of us have probably done something similar to this before, but it's interesting for me to go through these again over time, because sometimes where my strength was maybe 5 years ago has changed. Maybe what I value now is slightly different. So that'll be our assignment following this session. Here's just a visual, and I've put the link there. I apologize, part of it ended up under the logo, but a visual, sorry, for the different types of multiple intelligences. So if you get into this and you really feel like, hey, this is something I'm going to try to respond to in my classroom, having this up for students to see and helping them understand that, look, we're all smart in different ways, and helping them understand where they're smart and how they can use that to help benefit them as they study, right? So if I'm a picture smart, visual, spatial kind of person, well, that probably means I need a different study strategy than the person who is logical mathematical, right? That person who's logical mathematical, they probably are going to make the list. They're going to love things like outlines. They're going to love outline format. They're going to just eat up those strategies. And the visual spatial person, they might go along with it, but it's not the way that's going to respond. They're going to learn the best, right? Or that they're going to remember the most from. So we think about those things knowing that no one is 100% on any category, right? So just because I'm visual spatial doesn't mean I'm not also naturalistic, right? Or musical. So as we work through these, it's a very similar radar kind of diagram or jagged profile that I may fall anywhere on each of these lines based on my unique profile of who I am. So let's jump into the math now. So we've got kind of this hopefully a little bit of background or review on multiple intelligences. So our first one is looking at kindergarten through second grade and making a good guess. So we know if we put out a jar of jelly beans, or in this case goldfish or anything else, anybody can guess, right? But making a good estimation is something that takes a little bit more thinking. When we are asking kids to learn what it means to make an educated guess or a good guess, we're trying to teach them there are some strategies you can use, right? So they're going to look at goldfish, we're going to look at the distance between themselves and an object in the classroom, and then they're going to choose some activities based on how they would like to learn it. So we're going to start, like we have in all the other sessions, with something whole class that's just kind of engaging for everybody, that regardless of what your learning style is, this is a good chance to just get into the topic at hand. So maybe our whole class lesson or most of the class lesson. So you can see we're filling a jar or a baggie with some goldfish crackers, and man, I want to share this with everybody, but I'm not sure if I have enough. So how would I figure out if I have enough to share, or how many each person would get? Those kind of questions. So we're going to look at how many people are in our class, and then they're going to compare. We're going to put the number of crackers, or say we're doing the goldfish, right? So I had this jar over here that has all the goldfish in it, and I'm going to start a second jar that just has, there's 26 kids in my class. I might have a jar that just has 26 goldfish in it. And let's see what we can know, how does knowing that this is what 26 looks like impact what I think, or my estimate is for that large jar. So using kind of a reference point, right? So to compare the two, we're going to make sure that kids know that in that second jar, this is just one cracker for each person, and then ask everybody to make their estimates, right? We're going to record them on a chart paper, on our whiteboard, maybe even in an Excel document. Of course, this is K2, so probably going to do this on chart paper or on the board. And then we're going to go ahead and count them, right? We might count by 1s or 5s or 10s, however we're going to count the big jar. And let's talk about some of the academic vocabulary we've got going on here. Right? So more than, less than, closest to, furthest from the correct answer, closest to the correct answer. And then we're going to start comparing. So if I've done all these estimates on a number line, and I figure out that right here is the correct answer, we can talk about how many were below that point, how many were above it, how many were pretty close. And then a good guess, maybe we have to determine as a class, like, what would a good guess be? Is it being 5 off, being 10 off, being 100 off? It just depends on how many goldfish you're going to throw out there for them. And then we're going to try a different kind. So we've kind of done this visual estimate, right? And now we're going to do more of a bodily kinesthetic kind of estimate, right? So we're going to put a piece of tape on the floor. We're going to have students stand at that tape line and estimate how many steps is it going to take me to get to the other side of the room. So again, something that the vast majority of kids are going to engage in and be interested in. Of course, they're going to have to determine what means a step, because even large steps, small steps. So we're going to say heel to toe kind of steps, and even with that, we've got some little bit of error in there, but should be relatively close, right? So kids are going to step off their estimate. So if I estimate it's going to be 10 steps, and I'm going to step that off, and now we can look right across the room and see whose estimate was the closest, whose was the furthest off. So we've kind of created a real physical representation of our graph. Really neat idea at this point would be to either put marks on the floor at those points, or take a picture of it from up above, right, so that kids could see later, or in just throwing it up on a projector, well, where did we all end up, and who really was the closest, who was the furthest away. And then we're going to break into our kids' choice part, right? So this is page 90, the PDF's 95 to 97 here. So let's take a look at what those look like. So we're looking at one with beans in a jar, right? When we're looking at one that's bodily kinesthetic, where we're talking about, you look at the directions here, right, and see that we're going to see how many times can I do these activities. We're going to put our estimate down. We're going to set the timer for a minute and then do the activity. So how many times can I do a jumping jack in a minute? How many times can I hop in a minute? How many times can I toss the beanbag into the air and catch it in a minute? And then do the actual. So you can see we've got two very different activities going on. You might find that some kids choose the bodily kinesthetic and then decide they want to do something different. Because if you're really not into that, you might like it because you might think you're going to like it because you see the jumping around part. But we all kind of migrate to the things we really like. So if we move to the visual spatial learner, right? So here we're guessing how many craft sticks it's going to take to go across my desk. So they're going to put their estimate and then their actual. And then we're going to look at, we're going to count the sticks and we're going to write them down to see what it actually was. And then figure out, was it more or less? And then we're going to take that around the room, right? So we're going to use our visual spatial acuity here to go and say, okay, what else could I estimate? Is it maybe the distance across my teacher's desk? Maybe it's the height of the door. Maybe so giving kids some choice in that as well. So three different strategies, right? Starting with logical, mathematical, looking at bodily kinesthetic, and then visual spatial. And at the end, of course, we want kids to think about how they did with this. You don't have to do this on a piece of paper, right? We can do this on a smart board. We can do it with sticky notes that are even just hands up, right? So were you close when you estimated? Do you think it's easy? Do you think it's hard? And could you teach somebody else? So again, just getting kids to be a little bit metacognitive on that and think about how they're thinking about it. All right, so it's K2. So what does estimating with multiple intelligences in mind look like? And again, we want to be able to stretch these to any of our content or our strands in math. But so the 3-5 example is called the 3-minute shopping spree. So we're going to review some rounding principles because we're assuming by this point, especially with 4th and 5th grade, they've done some rounding. We're going to explain they're going to do a 3-minute shopping spree. They're going to try to spend as close as they can to $25. And then they're going to watch a demonstration of estimating the whole by estimating the parts, and then they'll get to pick some activities based on their intelligences. So again, whole class, large group activity. Here's the 3-minute shopping spree. You don't have time to add up the prices. You're going to have to estimate. You're going to try to spend as close to $25 without going over. And kind of a Price is Right scenario here, right? So first, wouldn't it be smart to have a strategy? Okay, well, so as a class, let's kind of talk about strategy. What do we know about rounding? And do we really gather that rounding helps us estimate, it helps us work with numbers mentally. So we're looking for friendly numbers, we're looking for numbers that I can keep in my head without too much drain on my working memory. We know that, see a typo there, so rounding, when we're rounding, how do we know when we're going to round up to the next greatest place value, and when are we going to stay the same? Really good idea to use a number line to show why, rounding by 5 we go up, or 5 or more we're going to go up to the next place value. Any connection to the number line is huge for our kids. So we're going to give kids the list of items here. So this is the 3-minute shopping spree list for their order form. We'll see this in the attachments, so hopefully you can pull that down if this is your grade level and would like that. They're going to check off what they would like. They're going to add them all up at the end of the 3 minutes. And if you have a group that seems like 3 minutes is too long for, that's okay. You can certainly make it a 1-minute shopping spree if you want to. Then we're going to look at the students who got the closest without going over. And the biggest part of this, right, is what strategy did you as a student use? Did you look for some things that were high dollar value, low dollar value, things that were close to the dollar? So that jump rope is $2.99. I know that's $3, so I can nail that one really fast. The nail clippers are $3, so I know that's 3 and 3. That's going to make 6. So what were your strategies? And then hopefully kids are talking to one another about which strategies they think are the better ones, the most efficient ones, because that's definitely that reflection on the math. And then they're going to choose their activity, right? So this first one has to do with front-end estimation. So instead of telling kids exactly what they're going to do, we're going to start with this, right? So we're going to say front-end estimation gets us pretty close, but it can also get us pretty far off on big values, right? So they're going to be looking at speed, how long it takes them to make their estimate, and then what is the actual answer. Let's see. Oops. So one of the other strategies would be looking at hopping distances, right? So how far can you hop in 16 hops, right? So we're going to work in groups. We're going to look at a measuring tape. We're going to think about how far do we think we could hop, so you can kind of connect to which multiple intelligence are we leaning towards here. Another one would be looking at estimating shapes, right? So they're going to start by themselves, and then they're going to exchange papers with a group of people, like 4 to 6 people. They're going to cut the edges off the paper. You can look at the directions here, right? And they're going to think about the number of shapes they trace. They're going to do all these pieces, right? And think about how many different ones did they get. And then finally, the one that we started with on this one, which was front-end estimation. So really just getting into more the logical, mathematical mindset. So in each one of these, we're working with estimation, but coming at it from a different angle. So we might say, well, but I have to have them estimate to a certain place value. And that's true, but there's a lot of ways to get to that versus than simply using the worksheets, right? So trying to think of ways we can bring in multiple intelligences into the standards that we know we all have to do, such as this one, right? Such as estimating. So that was the 3-5 example. The 6-8 example is called the Great Jelly Bean Estimation. I'm going to shrink this down just a little bit. I pulled up the wrong view there, so let me go over here to our, might fit a little better. Sorry, I'm going to jump through the slides. It doesn't let me start on a certain slide when I do it in this reading view, so appreciate you bearing with me just for a second here. All right, and here we go. All right, so, you know, a common motivator for kids and adults alike is food, right? So this is going to look similar on some level to the K2 example that we did with goldfish, right? So we're looking at four different multiple intelligence, four unique multiple intelligences, I should say. And it might take, this one's going to take a little bit of time, right? So we're still talking about estimation. Everybody's going to do one activity and then people are going to choose the other ones. And kids can be in groups of 3 for this. So the standards we're looking at here are the volume of rectangular prisms and looking at how do we gather data. And certainly that first one, volume of prisms, is one that kids can often follow the procedure for, but then they forget the procedure, right? And then they kind of fall apart. So estimating volume of prisms is certainly a big topic for us all. So the whole class activity, getting us all started at the same place. So kids are going to work in groups of 3. They're going to need the candy prism net and the jelly beans, and they're going to get this handout on the candy dispenser. And kids are going to get some time to work. So this is what those 2 sheets look like. So you can see the pretty typical prism net here that they can cut out and fold up. And you can see on the handout there, hopefully it's big enough for you to read. The Sweet Tooth Company has agreed to give the schools 5 jelly bean dispensers and to provide the jelly beans at no charge. The candy dispenser is a 6 by 6 by 6 inch cube, and it will dispense about 6 to 8 jelly beans per purchase, with each purchase costing the buyer a quarter. Right? So it tells in the directions. We're going to complete the activity to find the number of jelly beans that will fit into the dispenser itself, right? So we're going to fold this little box, the 6 by 6 by 1 inch box up, and that represents the dispenser itself. So then they're going to estimate how many jelly beans will fit in there. They're going to think about how big is the jelly bean, how big is this prism, and then share with us how did they come up with their number. So they're going to remain in their groups of 3 then. They're going to get the jelly bean project as the next step. So and again, this may certainly is going to happen, I would think, over at least 2 class periods, if not more. And then they're going to read over the assignment. Each kid in that group is going to get 1 section of the project to complete. And some of this is going to some of this part of the project goes back to that first candy dispenser activity. So they have to have done the candy dispenser activity first. So you can see here they have 3 different tasks, that they're being asked to do, and each one kind of lends itself towards a different type of learner. So you will see here that each group member is going to get a piece of the overall task. The first task being to conduct a survey, and then they're going to work towards displaying that data and deciding how to do that in an effective way. So we have to tell kids, hey, if you're going to collect survey responses, although they certainly could do it using technology, that they're going to have to do that before they come together for the next class period. Probably want to set a minimum number of responses so they don't have a group that gets 2 answers. And they're going to need to record their data. We as the teacher are probably going to need to just say, all right, 36 weeks in a school year, or this week we have 38, or this year we have 38 weeks, or something like that. But that's probably data that we're going to need to give them. The second and third day of the project is when the groups will come together because they'll have their data to complete the projects, and then they can share with one another. And so they have a little planner here, right? So that we make sure that kids are working together, that everybody knows what their responsibility is, and then they can list what they completed in the task. So if you're trying to give a grade on this, you can certainly assess independently and in terms of the group. When we get to this level, we're probably interested in how much kids have learned specifically to the standard. And so we might ask them some real direct questions like, if 5 jelly beans fit into a 1 inch by 1 inch square, how many are going to fit into a 4 inch by 4 inch square? And we can kind of tell by their responses what my next part of the instruction is going to be. And then a similar kind of follow-up question there too. All right, that's a beautiful slide. Sorry. So we're going to look at modeling linear behavior in grades 9, 12. And so the overview of this part of the PD, or this part of the lesson, is students are looking at velocity, looking at it in terms of slope on a time distance graph. For this one, you do need to probably, if you don't already have motion detectors, you need to borrow those or arrange for having those if you're going to do this way, the activity this way. There are some apps on phones now that will do this too, but these motion detectors are pretty prevalent in our high schools. They're also very available through UNCW, CSTEM, or the Science House at NC State, which is located just in Morehead City. So lots of motion detectors out there, but it does take asking for them to get them. So we're looking at mathematical modeling, and we are looking at rates of change, slope intercepts, and where our zeros are. So in terms of our whole class activity, we want to make sure that we've kind of activated the prior knowledge in terms of the rate is a comparison, right? Miles per gallon. It's the common vocabulary of per often comes up. We're usually looking at gas mileage, speed, how much somebody is making, what you get paid for doing certain tasks, those kind of things. When we look at motion detectors, I want to make sure that I show a little bit of an example of this, because I know different people have different experiences with things. So let's look at two things. I'm going to pull up the video first, and we'll go back and we'll pull up the actual activity here in a second. So this is from Vernier. Vernier is one of the primary, probably, creators or innovators when it comes to not just motion detectors, but all kinds of resources like this. So let me slide that over just a little bit. Let's just take a couple minutes to watch this. This is just kind of Vernier's overview of their motion detector.
This is the motion detector. It's one of our most popular sensors. It's used a lot in physics and physical science. It's used in the elementary book, middle school book. So it's used across a lot of different areas there. Let me give you just a quick overview of how it works. It actually uses echolocation and uses ultrasound. So it sends out a pulse of sound from the sensors. It goes out, bounces off an object, and comes back. And so it's really just measuring how far away the object is from the detector. And so it's using this part right here to do the detecting. A couple things about it here. You can open it up. And when you open it up, there's a switch on the inside that allows you to set it for what you're trying to do. If you're going to do something like walk in front of it or toss a ball in the air, you'd like to have the switch on this setting. If you're going to use it with a cart and track, you would put it on the other setting here, and you're adjusting the sensitivity. So that's what that's for. Now, to obtain data, all I'm going to do is plug it into the LabQuest, and it's a digital sensor, so it plugs in here at the top. And so it starts clicking, and so that tells me that it's working here. And I'm going to put it on its back so I can move my hand up and down over the detector. If you look at the meter screen now, it's actually giving a reading, and if I put my hand up here, you'll see that as I get closer to it, that the number gets smaller. As I move my hand away, the number gets larger. So again, it's just measuring how far away I am from the detector. Now, if I want to collect some data, all I need to do is press the collect button in that the lower left-hand corner. And so I'm going to press collect. And I'll put my hand over it and move my hand up and maybe let my hand go back down. So it collected data for 5 seconds. That's the default for that. You can change that to make it longer or shorter if you want to. And so now, the upper graph, I have a position time graph. And so as I moved away, you see that it go up. And as I move towards, it comes back down. The lower graph is a velocity graph based on the same data. So depending on what you're wanting to look for, you can do that. If you wanted to see just one of the graphs, you can change it very easily by tapping on where it says graph, and you can show graph, and I could show graph 1, and so there's just my position graph. I could look at just the velocity graph if I wanted to, but just leave it like this. Now, once I have some data, I might want to do a little bit of analysis there, and so I could go under Analyze, and there's a whole host of features there. What this is used for is that maybe the students, they analyze this, they're trying to figure out how far away the object moved, maybe how rapidly it moved, so that the tie to mathematics is great. And one of the things that research shows about using this sensor is that the fact that students have a real-time interaction with the graph helps them understand graphical data. They do have some kind of kinesthetic experience, maybe they're walking back and forth, and the students recognize that the graph means something because they've done this motion, and they get the two things together. And that's a very powerful feature to have, because you're trying to get your students to understand what the graph means, and this is a great device for making that happen. So again, it's used in a lot of the different areas, and it's definitely a great sensor to have. It's very popular, and students absolutely love using it.
All right, so pull that. Oops. Get us back where we belong here. There we are. So that's just in case you haven't seen these resources before. They certainly, Vernier creates a lot of resources for all the way back to 3rd grade. So although we're looking at using this for a 9-12 lesson here, I want to make sure that all our folks at the variety grade levels in this professional development know that this is available for all grade levels. So the lesson that is used in this professional development has to do with standing still, walking towards an object, speeding up, slowing down. What would graphs look like in terms of distance, in terms of velocity? How is velocity related to speed? When is velocity positive? When is it negative? What's that look like? Where's the y-intercept? So all those pieces, I want to make sure I bring up that although this professional development has this lab component to it, it's very, 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 very similar to what Vernier has created, and Vernier's is a little bit more detailed. So if this is interesting to you, there are guidebooks for all these, but this is one that's just online as a do not duplicate kind of copy, an evaluation copy. So if you just Google this, it'll come up, but I also put the link in there. So sometimes it's just nice to have the step-by-step piece. It gives you the student pieces, it gives you your piece, and there's many, many more of these lab type things from Vernier, and they've done a great job of putting them together in ways that work, like I say, all the way from 3rd grade on up. So we're looking at giving kids a chance to interact with graphs, and more than just how does the graph represent the data, but, well, how did that data get created? So let's take a look at what that looks like here in this lesson, right? So in our whole class activity, we're going to have volunteers walk towards the motion detector. They're going to walk back. We're going to create some graphs. We're going to kind of analyze those. Once kids have done it once or twice, we're going to start talking about strategies. So like, if I want it to tell me that this person starts further away and comes towards the motion detector, where should they start? How should they be walking? Should they be walking faster, slower, speeding up, walking the same pace? There's so many good questions here that bring in the math and the graphing. So we have this out walking activity sheet. We'll pull that up here in just a second. They're going to do part 1, and then talk about the relationship between slope and the speed the person is moving. So negative slope is one that is a topic that, depending on the grade level you're working with, is certainly one you may have to discuss and spend a little extra time with. And then what is the difference between speed and velocity? And we know that velocity is speed in a particular direction, but kids don't always know that, right? And so that's a big idea of physical science as well as just math. So here's our out walking, and here's part 1, right? So they're going to start 2 feet from the wall, take 3 seconds to move slowly away from the wall, and by the wall they're talking about where the detector is, right? And then stand still, and they're going to do these other things, and then they're going to draw out their sketches for each one of those. So they're gathering some data, building some knowledge, building some understanding, and then we're going to move towards kind of pulling that together as a large group. So let's now create a graph as a big group. So everybody's had this experience. Now let's create a graph in which the walker would move at this rate, right? And then they change their velocity, and then they move at a different velocity to a different distance. So now we're starting to say, if I want the data to read this way, what would the walker be doing, and what would the graph look like? And you could certainly flip it around, right? So that worksheet looks something like this, right? So each of these graphs represents something. How would you create that graph? What would the person be doing? What would it actually look like? And then as an assessment, and again, this could certainly be done over time, giving the students a graph and describe the motion. This gets a little tricky, right? When you're looking at speed versus distance graphs and velocity graphs and all kinds of things. So you can make this as rigorous as you would like. And then ultimately we want to be able to give the kids a scenario and have them create the graph that goes along with it. So as we come to the conclusion of this session, session 4, we come back to our definition, as we will in each session, of differentiation. So our definition of differentiation is that which Carol Ann Tomlinson has shared for years, which is simply our willingness and our ability to attend to the learning needs of our students, and understanding that our large group of students, there's a lot of variation in that group of kids, just like there is in each one of us. We know that we can vary the content, we can vary the process, we can vary the learning environment, we can vary the products, and at times the learner can vary himself or herself, and as teachers we can vary the way that we conduct ourselves and the things that we do. So as you think about multiple intelligences, we're generally maintaining content, right? The content is generally the same content, but we're adjusting the way that kids are going to go about learning it. So it may involve adjusting the learning environment too. And it almost always involves varying the product, so how they'll share their knowledge back with us, and that is to reflect their multiple intelligences. We'll remember this visual, hopefully, from each of our sessions, right, that what's equal is not always fair, right, and it doesn't give everybody the chance to learn things, and no one is disenfranchised by differentiating something. That we're really just making it possible for everybody. We're not changing anything for the person who doesn't need it changed. So our next session is via Edmodo as well, and that will be posted soon around February 25th. So that session is on concrete representation on abstract. And then our March 8th session, which was originally scheduled for face-to-face, that happens to be the same date as our Magnet School Lottery, which I have to be at. So I'll be flipping that lesson as well, and that March 8th lesson is on choice boards. So that's usually one of the favorite ones. Choices is probably the most powerful of all the differentiation strategies. So I thank you again for your time here today, and I look forward to seeing your homework. Make sure I didn't put it on this slide, but remember that your assignment for this session is to do your profile on that Excel spreadsheet and to share that as a post. So thank you again for your time, and I look forward to seeing you or hearing from you online.